Cool. Let's start. So today is March 23rd, and the tech meeting will have like 3 topics. So first one will from our new incoming committer Emo, and he's going to talk about the MEP 24, which is how Milvus can support backloading. And I thought there'll be like many interesting tech details for the topics. And the second one will come from Jamie and Xi Chen, and they are going to talk about how to support Kafka as message storage for Milvus. And third one will from myself. I'm going to introduce a little bit about the membership, community membership. If you are interested to become a contributor, a committer, or even a maintainer for the Milvus project, we're going to discuss some of the details about how we set the threshold and what we want all those members in the community to have. So feel free to give comments or ask questions. Okay, so Mo, are you ready for the present?
Yeah, let me share my screen.
Sure. So share.
Can you see my screen?
No? It's ducking. Just wait for a few minutes. Okay. We can't. Anybody else? I just can't see anything. Oh, okay.
Okay.
Yeah.
Okay. The screen is the MEP page for the backload, right?
Yes, it's MEP 24. Yeah.
Okay. So this is a new feature. We are planning to implement it in the version 2.1. Yes, we are in coding stage. I feel it is a challenge to implement it in the version 2.1, but we will try make it as possible as we can, right? Okay, let's begin. So this feature is to get better performance than the insert interface. Because as we know, the insert interface is a bit slowly when insert a large data set. Our QA team report that when they are importing a large data set with 10 billion vectors with 128 dimensions, it will cost 5 or 6 hours to import them. So we designed this in new interface to use another approach to import a large data set. The brief design is like this graph. We will not pass all the data from the SDK to the proxy and finally to the data node. We will use another approach. We just pass a file path to the new interface. The new interface will pass these file paths and some options to the proxy, and proxy will pass these options and file paths to data cord or data node. And finally, the data node will open the file. Firstly, it download the file from the minimal storage, and then pass the file in the data node and consume the data and convert them into the segment. This is the brief approach of these new features. new feature. Yeah. Then yes, we have a scope for these features. We support first stage. We will support the JSON format files and NumPy format files. For JSON format files, we only support import them as a row-based format. The NumPy format is only for column-based data, column-based format. And yes, this is another graph about how this how these features works. The important interface will pass the options. The options will contain some fast paths. The fast path is a relate path. It is a relate path from the minial storage, and will specify the collection name and partition name. And some other options is the row-based or column-based. It is a Boolean parameter. And yes, and we will allow the user to specify a partition name for the minial storage. The import options will be passed by the root call. The root call will transfer the import parameters into some import tasks. The import tasks will pass to data code, and data code will assign a idle data node to pass the to handle the import tasks. Yes, the data node will download the file. Firstly, it's download the file from the minial storage, and then it's validate the JSON file and convert the data into segment. And finally, the segment will save into the minial storage again. The etcd is used to store the meta of the import tasks, because we will record these tasks in for users, because users will call the get import state to get the state of import tasks at any time. Yeah, so we use etcd to store these informations. In the SDK side, we designed two interface for this feature. The first is the import interface. This is Python interface. We can see there are some parameters, including the collection name, partition name, and files. Files is a list. The list is some JSON files that you can start multiple import tasks for each file. The row-based is a Boolean. Yeah. What is the row-based and column-based? That here is an example. A row-based JSON format is like this. We will require the root node is the name is rows. This is for row-based JSON files. User must generate such kind of JSON files in their minial storage. Then we will pass this JSON in the data node. The row-based JSON files, we can see he write the rows one by one. And this here is the column-based data file. Each key is a name of the collection field. Assume there are two fields in this collection. One is UID, another is vector. Then we write these column-based files like this. Yeah. Then this parameter is used to tell the data node this file is a row-based format or a column-based format. And the options will can contain some extra parameters that user can specify, including the bucket name. Yes, bucket name. Then this interface return a list of task IDs. We know each import task is a time-consuming work. It cannot return advanced result to users. So this interface will return instantly when after the user call. It just do some basic validation. For example, is the collection exist or the partition exist, and the bucket name is illegal or not. So user will use another API to get the import state. He will import a task ID. The task ID is an ID returned from the import interface. From the API, user can get the state of import task, including the its state, how many row count is consumed by the task, and the progress percent, I think, yeah. And the failed region if this task is failed, and ID list for the outer ID field, and which file this task is passing. Yeah, the state including the following values. Pending means the task is in pending state. Yeah, the pending state is still in the root core, not passed to data node. Started means this task has already been sent to a data node to work. Downloaded state means the data node has already downloaded the JSON file from the minial storage, and passed indicated the data node has finished the passing of this JSON file. Persist means the data node has persist all the segment to the minial storage. And complete means the generated segment has been indexed. Yes, we divide the work. We divide the complete state as the task. All the segment of the task must be indexed. Then it will be marked as complete. Failed means this task has been failed with some reasons. The failed reason may occur in the start state or download state or pass state or persist state at any stage. It is possible to fail. We will tell the user why it's failed. Once the task is failed, then we will not allow any data of the task to be consumed into the database. So if user seen a task is failed, then he can make some fix for the JSON file and resend a request to import the file again. So yeah, this is a row-based, column-based. So there is a error handling. Some errors will occur if the validation is not passed, including the collection doesn't exist, partition doesn't exist, and bucket name doesn't exist. and file dynasty exists. And we know we cannot allow the user to always send import requests to our database, because there need to be a limitation to pending for the pending tasks. So we define a limit size for the pending tasks. This limited size is 32 or 64. If the user imported the user imported request exceed this limit size, we will return the error by the import interface to tell user that you cannot import so many tasks into the Milvus. And more errors will return by the get import state, because the importer just do some basic validation. Most of the validation is done by the data node. That means that the most of the errors is returned by the get import state. The errors including the file dynasty exist, and the JSON format is illegal, and some other details such as the vector dimension is not matched, and the value type is not matched. And we define a limitation for the file size. Each import files should be less than 1 GB. Yeah. This is for the, we don't intend to pass a huge files in the data node. If a task is no response for more than six hours, or some, yes, the 6 hours is maybe is 4 or 2 hours is more better. But anyway, if an import task is no response for a long time, we will mark it as failed, because we don't know what happens for the task. Maybe the data node is busy, or data node is hangs or crashed. So if it's no response for a long time, we will mark this as failed. Maybe some errors may occur by the data core or data node machinery. When data node is crashed or restarted, the data core will report the failed data node to the root core, so that the root core will mark the related important task to be failed. The left is the detailed design of the internal machinery. In proto level, we also defined 2 methods. And this is the proto structure, import state. And for the local level, we will define 3 methods, because the report import method is for internal use. It is called by data node or data core. When data node finish import task, he will call this method to report to the root core that the import task is finished or in some middle stage. So for each stage of the task, the root core will get info, and it will update the state of the task list in the etcd. The reported information is including the task ID and import state and how many segment is generated by the task, and how many ID is auto-generated by these tasks, and how many local is generated, and some other informations. Yeah. So this graph is a internal core train of the import workflow. When import request received from SDK, the proxy will directly send the import request to the root core. The root core will maintain a task list for import. It will convert the import request into multiple import tasks and send this and push these import tasks to data core. The data core will pick up a idle data node to execute when import tasks. So there may be many data nodes in this level, and data core, and maybe there are many import tasks executed at the same time. When data node finishes the persist stage, he will send the save bin log path to data log to generate a sealed segment, right? And he will call the some API from the root core to generate the ID for the new generate rows. After it finishes a stage, it will call the report import method to the root core, so that the root core to update the task stated. After the segment is persist, the root core will monitor the index progress of each segment to know whether the import task is finished, because we say only each segment is indexed. The import task, we can say it's complete. So finally, the root core will monitor the index code to get an index state from for each segment. It will finally it will update the task to be complete, so that the user can know import task is finished. And this is the API of the data code. It's only send import task to data node. For import request, we will do some different logic for row-based JSON files or column-based files. For row-based, user can input multiple files in a request. The root core will convert it into some import tasks. But for the column-based, this is the type. For column-based files, the import request will be converted into one import tasks. The left is some details about how we implement it. For deletion, we say the buckler will ignore all the deletion actions during importing. Once after all the JSON file has been persist and indexed, has been persist, right? Then the deletion will be take effect to the persist segment. But during the import, we will not allow deletion action to take effect to the import tasks. So there's some, yeah, there's some internal machinery of the after backload. So that is all. Any questions?
Okay. So I have one question. So could you go back to the flow of the load request? Okay. So when the data node executes the import task, right? Because it will first do we support auto-generated primary key?
Yes, the data node will generate the auto ID for each JSON file, and yeah, he will
So
call
user
the.
can specify primary key, or if it's not specified, it will automatically generate it, right?
I think it depends on the collection schema. If the user, the collection schema including auto ID primary key, then the user will not input such a field for the JSON files in the JSON files.
Okay. So another question would be if so when you try to do assign segment ID, right? For each of the entity, it will go through the data cord, or it's going to be a batch. If it's a batch, then the question will be, since we currently for the insert, right, we hash each primary key and assign a different segment based on the hash value, right? Are we for the backload?
Yeah, the backload will do same logic to similar to the insert interface. He will hash the primary key and distribute the primary key to multiple segment. So each JSON file it will generate multiple segment according to the thread number.
Okay. So even if you backload a really small number of entities, let's say only 100 entities, it will generate maybe four, let's say if you have 4 shards, it will generate 4 different segments, right?
Yes. Yes.
Okay, so backload entities will never be in the same segment as insert values, right? Let's say if you're trying to like backload for segment A, and meanwhile the insert it still happen, right? The data cord will make sure that backload value will not be in the same segment as the insert value, right?
I think so. Maybe more than to get your question.
Okay, so the question will be, let's say, because backload will be happens together with the insertion, right? So for the data, are they share the same segments, or they are always using different segments?
I think they should use the different segment IDs, since the segment assign logic will be different for import tasks and insert tasks.
Okay, cool. That's answered my question. Sure.
Yeah.
Go ahead, please.
No, I just have some detail. I'm not sure because I still in learning the internal machinery of the persist process. So I think Chongqi answer to the question is more better. I'm not sure the answer, right?
Sure, we can have some discussion like in the MEP later about how we set the segment IDs. Okay. Also for the timestamp, right? So for each entity in Milvus, there should be one timestamp. For the backload data, are we going to assign all the timestamp in one call to the TSO, or it also separate to multiple calls?
Yes, the timestamp can be can be a timestamp when the import task is done. So
Okay, so it's
that
only going to assign when the import task is done.
yes,
Like
all
already.
the items use same timestamp. The timestamp can be assigned when the import task is done.
Okay, so all the entities are trying to use the same timestamp. Okay.
I suppose so. Yeah.
Okay, so the good part will be there should be a MVCC support, so all the data should be like able to be invisible, like visible at the same time. Okay, but I'm not sure for the current case, because for the current case, when you batch insert, each entity should have a different timestamp, but they should be really close. So I'm not sure which one will be better.
We discussed this in our meeting. We think it is better to set a new state for segment. The new state is flashing state. So when segment is in flashing state, they are not they are invisible. After all the import task is done, all the segment is persisted, then they can be visible.
Cool, understand. Any other questions?
Hello, I have one question. Could you go back to the parameter explanation part of the
Parameter for the
yes.
SDK?
Yes.
Here.
Is the parameter role-based required or optional?
Role-based is required. You must input true or false to specify the role-based format or column-based format.
Okay, so if the role-based value isn't matched with the files, it will report error messages.
So you mean if the role-based is true, but the JSON file is column format, right?
Yes.
Yeah. Yes, it will return error in the validation stage. The user will get this error by the get import state, because this error is through from the data node.
Okay. And I'm wondering for the state, get import state. I say there are a lot of stages for state for the state parameter in the return values, such like paid-in, started, downloaded, and so. Is it necessary to let users to know so much states?
I think the user mostly focus on the stage of complete or failed. The other state is for more information for them, I think.
Yes, so I think maybe the state should be completed or failed, and the failed reason should be more detailed, such as like downloaded failed or and so on.
The fail reason, is more detailed. This I think this is depend on how we write code.
Okay, I just gave some suggestions. Okay, that's all. Thank you.
Yeah, I have comments for the same items about the state. I think this state pending, started, download is too many, and it is too kind of engineering on engineering view. I think as user we should use user language to talk about this state. As also, I think we need a flow for this kind of state. to help the user understand how this state transfers between different states, just like the float in the below, and you can mark the state here as just a piece of suggestion.
Yes, we can provide more documentations about the detail of this feature and put
I think I think we can use appending to indicate that the task is still in kind of validation, or we can just use validation in validation, or in loading, or in indexing and complete, so to make it shorter.
Which one you think is useless?
I think not useless. I mean, it's not specific which stage or which what is running, or what is, or it's not, the user cannot get enough information for him what he should do, or what he should just wait, or he should just do something more to make it complete. Yeah. So I mean, the state should be more meaningful, or more kind of have some guide information for the user.
Yeah, such as if you say persisted, actually I have little messages about what has happened, and yeah.
I think this is the problem, that how we write the documentation. We can provide more detail about these stages, but this stages is according to the process of the internally machinery. Each stage is meaningful to the internal machinery. We are using this stage to do some actual works, such as the pending. From the pending stage, we can know the task is not sending to data node. It is still in root core, and when it become started, then we know it is already been sent to the data node and downloaded.
Sorry, go on.
Yeah.
Can I just? Sorry. May I interrupt? I just want to say that these states are most used. So all the states you're looking at right now are more like internal states, and that's so at this stage we haven't separated the internal states from the states we expose to the users. So just exposing the same states like altogether to the users. So on my side, when I look at this, it's like when user look at when user like to check like how are like where are my tasks, like where are my tasks are going, they can just pull a list of the tasks and see their status, right? So there are two things they can see. The first thing is the state, which is like pending, started, downloaded, parsed, whatever. The second thing is the fail reason. The fail reason is the detailed error message indicating whether like how the task failed, or like is it stuck or something. So there are two things that this state can help us. The first is that when so there's say this task failed, and the user has no idea like where, like what is going on, they can just let us know, like, okay, my task is in a downloaded state, and they'll let us know. And when we're looking at this, we can see, okay, the file has been downloaded, but apparently, like, the next phase after downloaded has failed, so it can help us do debugging. The second thing is, these states can help us do failover internally. I would have to say. So that means if we know, like, exactly which state has failed, so this can help us to failover in that case when our system fails. So let's say our data node crashed, we can, when it comes back online, we can figure out that, okay, this task is in a downloaded state, so we can just recover from there. So what I'm trying to say is that these states are more like internal states that can help us a lot. But whether the question is whether we should expose all these states to the users. We can either, just expose all these states as they were, and another option is to do a mapping, like we map, like, pending, started, downloaded to a new state, and parsed, persisted to another state, something like that, so we can expose less states to the users.
Yes,
something to think about.
Yes, I agree.
I will say another point. The tool interface is about the SDK interface, about the in SDK level. We have ORM level, right? So we can hide some state that we don't want to expose to users in the ORM level. So that this SDK level is a lower level for the SDK, right? So each SDK can do some, can implement the ORM level to expose only the complete or the failed state for users if we want.
Okay,
Yeah,
that makes sense.
Okay.
It's just, yeah. Okay, so I think we got kind of the agreement. We're going to head in of some of the details for the users. Since we are running out of time, I think we should move on to the next topic. Okay, if you guys have any other questions, feel free to leave comments on the MEP 24 or for the GitHub issue, and maybe you can directly go to Mo's Slack or Alex's Slack and keep for the discussion. Okay, so next topic, we're going to talk about Kafka support, which is also expected by many of our users, because Kafka is the most popular streaming storage to date. Xi, are you ready for the presentation?
Xi Chen is busy. I will to talk. I will to share it.
Okay, sure.
Okay, let's share.
We're probably running on time, so I guess we have like another 10 or 15 minutes to go through the Kafka support. Yeah.
Okay. I will share I will share topic about support Milvus Milvus support Kafka. Yeah. as well as you know, Kafka is distribute event store and the message process platform. It is a very popular solution to serve data streaming need. Our Milvus have a logo broker as a pub sub system. Now, Milvus cluster mode use POSA as a logo broker, and standalone mode use Rox MQ. Which is based on which implement based on RocksDB. Yeah. Today, many community users expect Milvus to support Kafka. I think there's 2 points. First one, the user have already used it as has already used Kafka in the production environment, and Kafka is more stability and have more throughput than POSA. As well known, Kafka have different architecture with architecture than POSA. Yeah. Kafka cluster is more simple. And we will support Kafka as a message stream by providing configuration option to decide to use the POSA or Kafka on cluster mode. And we also discuss about standalone mode to support POSA or Kafka. I saw a standalone mode needed to use POSA or Kafka when debug Milvus. Yeah. The follow there is a Milvus YAML. If we use Kafka, we can to configure a Kafka broker to use to connect the Kafka brokers to connect Kafka servers. About design details, there is and something for configuration. if Kafka and POSA configure at sometimes in Milvus YAML, POSA has a higher priority to use. Milvus supports Kafka. We need to decide to use the Kafka client SDK. There are two SDK we need two SDK, Samsung and Complement Kafka Go. Where we try to implement we try to implement it. We found I found this SD Samsung and Complement Kafka Go are so many different so many difference. Yeah. Kafka has a consumer groups conception. Have a consumer groups API. We need to implement message queue by master use it. Yeah. Kafka Go provides a simple interface, but Samsung Samsung will try, but Samsung is use it, but Samsung is too hard. We use it. Complement Kafka Go SDK use consumer go to group to consume message with just a function. Yeah. I have a lot about consumer message on Kafka. Complement Kafka Go will Complement Kafka Go have offer two interface to consumer message. One is function based. Yeah. Another is channel based. Yeah. But the Complement community more Complement community recommend developer to use function based interface. So this function will learn to use we use to consumer message like iterator like the API. So how to implement it? Yeah. I think I think there is three interface to implement. One is the consumer interface, and produce interface, and factory interface. Yeah, there are this interface must be implemented. But another worker need to do about to provide providing a unified MQ interface. We reconstruct some API. One thing is removing a service reader API from message streaming interface. Actually, Kafka doesn't support reader API. I saw reader API only supports in POSA client. It's not a general solution. It's also implemented by consumer API. So we decided to remove reader interface from Milvus project. So we also reconstruct factory set permit API. We replace it with the init API. Yeah. Now so many permits we write the Milvus code directly.
Sorry, I'm going to interrupt. Since we're running out of time, can you just finish in like 5 or 10 minutes? Yeah.
Okay. Okay. Last one we talk about development. There are two development. There is two development types. One is standalone. Another is class. About standalone, we need to support a Kafka Docker Compose. Kafka Docker Compose development. Yeah. Last, we also need to support him chat and operator to deployment on the KBase cluster. The last part is test plan. Is testing plan. We have another testing plan about to test about to test Kafka. As we we will plan to test Kafka to do some cost testing. We will add some costs into Kafka, such as balancing or scale in or scale out Kafka cluster. Yeah. Okay, that's all. Any questions?
I have one question. So when will we like what's the timeline? So when will the code check into the master branch? And what are we going to like recommend Kafka as our first choice, or we'll leave it together with POSA and we'll still keep POSA as the massive storage default solution?
We will release this feature in with Milvus 2.1. Yeah. And I think we will use POSA as a message queue in certain months. Yeah. Kafka solution need to need to do something make it more stability, more stable. Yeah.
Yeah. So in short, I think Kafka will not replace POSA as a default in Milvus we should collect more feedback from the community and from our testing result to determine that we replace Kafka with we replace POSA with Kafka or not. So this should take about 2, 3, or 6 months, I think.
Yeah, I think about 3 months. Yeah, I see.
Okay. So let's see what's going to be happening for the 2.2, and I think it's a big progress once we bring in the Kafka support for 2.1, because I know a lot of users that they're looking forward to the Kafka support. So another question for Yanliang. So are we going to support Kafka benchmark compared to POSA before we release 2.0 or 2.1, or we'll leave it after we release 2.1?
It depends on the schedule. I think it's mostly it should after 2.1 for Kafka benchmark. Yeah. But we it should be like the Milvus 2.0. So after we release 2.1 and after a few weeks, we can release a benchmark report for Kafka, Milvus with Kafka. Yeah.
Okay. So any other questions for the Kafka support? Okay. So if no, I guess that's pretty much for today's tech meeting. Since we're running out of time, I think I'm gonna do like push membership to the next tech meeting, which will be held on April, let's say April 27th. So another thing I'm going to show is the Milvus hoodie. We have plenty of those hoodies. So if you like this, probably you can contribute to the community and connect me at Slack. I think we'll offer a few goodies to the contributors who actively push to the Git repo. Okay, so that's pretty much for today's tech meeting. Thank you guys for the attendance and hope to see you next month. I think we're going to release 2.02 this week, maybe next Monday or this Friday. And for the 2.1, I think everything is in check. We're going to phrase our code at the beginning of the April, and since then we're going to do more tests about the 2.1 new features, and we're trying to deliver the 2.1 RC version in the middle of April. Okay, so let me know if you have any questions, or if you have any issues, we can still discuss on the Slack or our GitHub. Cool. Thank you. See you guys.
See you.